Hey students, today we're going to talk about graphical analysis, which is a really important part of doing any science, particularly the physical sciences like chemistry and physics, but it's relevant to all kinds of sciences, including social sciences. Basically what graphical analysis is making sense of numbers, and it's important for us to make sense of numbers because science is all about analyzing numbers to look for patterns and trends and build models that are predictive. It's been said a picture is worth 1,000 words. It's a kind of a famous saying. And this illustration that we see here, this painting, is a good example of what that means. If you look at this painting, you can see at a glance, just by looking at it, a number of things that you know must be true. Looks like it's fall because there's maybe some ice on the roadway. They're picking pumpkins up. There are geese flying south. Leaves have turned and are starting to fall off the trees. It looks like it's around dusk or early evening because the sky is dark, the moon is up, the lights are on in the store. It looks like it's maybe cold because people are wearing coats, and you can tell details about what kind of truck this is, and maybe if you look closely at the signs you could get more information about where the store is. A lot of information can be built into this picture, and if you look at it, the longer you look at it, the more details you see, the more information you get about what the artist was trying to portray here. If you were to try to describe to someone this picture in all of its detail using an essay, you would have to write a really long essay. You have to write a lot of words to be able to convey what's in this picture that you can see at a glance, all of this information. Well, there's a numbers version of this too that's really important to scientists, and that is this idea that a graph is worth 1,000 numbers. Here's what we mean by that. If you take a look at a bunch of numerical data like we see in this spreadsheet here, it can be overwhelming. There's information built into that data somewhere, but just looking at rows and rows of data, it's really hard to see that. But if you take this same data and you put it in a graph, sometimes the meaning pops right out at you and it becomes much clearer. How are things changing? What are the values like? How could we make a prediction about what's going to happen next? That becomes much easier when you have a graph. So we're going to use some of our time in this course to figure out how we can take the results of our experiments and turn them into meaningful models using graphical analysis. Here are some key questions. The first thing we want to ask ourselves is, how can we design experiments to give us useful data? So an experiment is not just a random fooling around with something and writing down some numbers once in a while. Good experiments are designed so that we can get data that is more likely to produce a useful model than not. Another key question is, what's a coordinate axis system and how can it help? This is a tool that we're going to use over and over again, so we need to spend a little time talking about it. Another question is, how can we know if a line is a good way to model the data? The reason we want to know the answer to this is because the math of lines is easy math, and so we want to be able to spot lines if they're present and then know what to do if a line isn't a good model. Another thing we want to know is, how can we use a math equation as a shorthand for a line? So rather than having to draw a graph and draw a line and then read off that graph, there is a quick way that we can condense a math equation out of a graph and have this little shorthand input and output device that can help us use our model to make predictions very easily. And then the last question is, what can we do if a line isn't a good model? Because we know lines are easy to use. What if we don't have a line? Well, there's something that we can do to deal with it, and we'll have to learn about that as well. So this is a setup for the first unit in our course where we learn about how to build mathematical models based on experimental data. So we're going to learn about how to do experiments, how to represent the data, how to build a model out of that data, and do that effectively so we can be scientists.